Hey everybody, this is Larry. This is day 23 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, 592, fraction, addition, and subtraction. Today I didn't do that much. I ran 10 miles at marathon pace and just so tired. But it's going to be this way for the next 2 months until the marathon. Hopefully it gets a little bit easier because today I think I'm just a little bit physically tired, not mentally as much, though I could probably be less tired in general. So yeah, very excited for that, or very excited to be over, to be honest. But for now, still working on it. All right, let's take a look at today's problem. So given a string expression representing an expression of fraction, addition, and subtraction, return the calculation result in string format. The final result should be an irreducible fraction. If your final result is an integer, change it to the format of fraction as down. Okay. Okay. I mean, I think that the first thing to do is kind of think about what you want to do with this problem, right? For this particular problem, there are actually two problems, right? I mean, you know, there may be more if you want to think about it, but two main components. One is the parsing, and then the second is just doing the math. Parsing, we probably have to kind of, at least for me, parsing is always kind of tricky to think about all the test or edge cases in general. I mean, for like general parsing things. Maybe this problem will be a little bit easier. We'll kind of examine it. But almost by definition, every parsing problem is like a little bit unique. It's either that or it's something that, like, I don't know, some paren stack-based thing, but that's still like sometimes could be tricky, right? The math part, I think technically speaking, Python does have a library for it, which probably surprises no one really. And another thing that people sometimes do is use imaginary numbers and stuff like that. We don't have. We could keep it simple, right? And maybe we'll just write our own fraction class. And that'll probably be what we'll end up doing, just for, keep everything straightforward. And therefore that allows us to kind of have our parse logic with the the parse logic and then the math part separately in theory, right? Just having separation of responsibilities. And these are things that I just want to point out that I think about every problem for the most part. On Leetcode, you don't need to express it that much, but sometimes I talk about it. Like, even if I don't, like, I think one of my philosophies is that each function should be less than, say, I don't know. I think there is like a good design or good pattern thing that people talk about being like 5 lines of code or less. I don't know if I agree with the 5 lines of code or less per se, but I like that each function has one idea of calculation, right? Just like one thing that it's supposed to be doing. And usually, if you do it in a modular way, a clean way, a testable way, you should be able to do it in, like, say 10 lines or something like this, right? Maybe like a couple of if statements, or maybe certain functions are a little bit longer depending on what you need to do. But that's how I would think about it. But that said, if you watch my video, I don't always do that because it's not necessary. But still, even if I don't separate them into a function, you see blocks of code where you can see that I talk about it sometimes also in terms of invariance, where after certain blocks of code, you know that certain invariants are true, or certain things are true, right? So that's basically the idea. Okay, so we talked about it a lot. Let's see. Oh, denominator. Okay, let's look at the constraints real quick. Is what I'm doing. Sorry. So okay, so it only has plus minus, and so there's the input. The number of given fractions, the number will be up at least up to 10 numbers. Don't know why they have 10. I feel like it's kind of weird, or not that weird, but it, like, I don't know, it would make it so much easier if this was up to 9, I guess, is what I was trying to say. But it's also not a big deal for this particular problem. I don't think. And we had a parsing problem yesterday, right? Or did I make that up? No, we didn't. I did it as one of my bonus questions, I think, for serialized, deserialized tree or something. You could watch that if you like. So I did do a parsing thing yesterday, so it's kind of good. So yeah, I mean, I think that these things are always a little bit tricky in the sense of how you want to write the parser, because, like I said, most parsers are going to be different every time. Because, I mean, maybe not always. I mean, there is some stuff about like calculators and stuff like that, that if you practice enough, I guess you get, you know, the same ideas or similar ideas. But very often, it's just very custom because they give you the rules and the rules are a little bit, you know, different, right? Okay. I mean, I think the first thing I would like to, I think there are a couple of things, and yeah, I mean, I think there are two, for this particular problem, I'm thinking of the two ideas, right, that you can approach with the parsing. One is just writing a custom part, like very, very custom to these specific constraints. And then the other is just writing a language parser, right? Because you can express this in a pretty simple language and then just parse one character at a time, which is also fine, probably. But it just depends on how you want to think about it. Yeah, okay. I mean, let's just do the parsing one character at a time thing, right? So that means that now, what are the components, right? So we have a get sign, maybe, or parse sign, or maybe parse sign, right? Though that's a little bit awkward because it only applies to the first character, because everyone after that has that. But then, yeah, these are the functions. If you kind of think about writing a language, and I say language in the programming language kind of way, you could write a language for the not in the programming language. I mean, I guess so, but language in the like what was it called? Like a finite state automata and all these what's it called? Like a natural language kind of, not natural language. I'm missing the terminology. It's been so long, so my apologies if I'm messing up on the terminology for sure. But basically, yeah, like a language that syntax that describe the language with all these like items, right? So there are a couple of things which is like, you know, maybe parse number, right? Which, you know, like if you want to write the language, you have something like you know, you have a numerator, right? So it could be like 1 to 10, or like 0 to 9, say, right? Or actually, I guess in theory you should supposed to write this as an int or a number or something like this. You have a denominator, which is also an int or number. I guess maybe we'll just write number, because in theory you can also write like numbers in int. And then here, you know, you have a language that is, I forget how to write it. I forget how to write optional stuff. It's been a while. But like maybe you have a sign, and then you have a fraction, right? So you could write fraction is equal to a numerator, the divisor or whatever operator, something like that, right? And then and maybe optional sign, I don't know, that's quite whatever, right? And then an expression in this case, right, like this is how you would write out the exact language. I mean, I think I'm a little bit wrong on the language due to this optional sign thing. I think I forget how to I forget the exact way of doing it, honestly. But yeah, an expression is just I also forget how to do it. Fraction expression, maybe something like this, right? Or fraction. I guess that's kind of right, because I mean, this. I guess technically this is an. because the thing that with this one is that it does combine like sign and operator. So it depends how you want to think about it, right? In the sense that you can think about a sign as, but in this case, this is not optional, right? For the non-first one, because you can think about it as two ways, right? Sign with no operator, and then the implicit operator is just adding all the time, or an operator with the thing, right? So maybe you could think about it like, you know, something like this, right? And then operator is just like maybe there's an optional sign, and sign is equal to you know, plus or minus, right? Something like this. I forget the exact notations. Notation is the word I was looking for. And operation is also plus minus. Right? So like you can write out this language, and then and from this language you can write out the parser from it, right? So yeah, yeah. I mean, I think that's kind of the idea that I was going for. Like I said, the notation may be a little bit off because I don't know, right? Int, which is from 0 to 9 or something. But you know, you get the idea that I'm trying to do. So then now we have a parse expression, which is the thing that we're doing now, right? Yeah. And so then now we check whether this is a so the first thing has to be a fraction. So then we can just do fraction is equal to parse fraction, right? And the reason why I these things usually takes a local or a global indexing on the expression, which is why it looks a little bit awkward. But I don't know. I mean, you could also like, you know, so parse fraction. So I guess maybe you could even put this inside of parse expression in Python. I don't know, right? And but yeah, and then op is equal to parse op, right? And then oh, I guess it doesn't have to. I guess these are optionals. I forget how to express optionals. I think maybe it's let's say syntax optional. Let me try to Google it. Language. I forget how the exact formal notation. It's been a long time. Yeah, and I don't even know what to Google for it anymore, to be honest. I don't know, but yeah. So something like this, right? So then now, if it's not over, because I think this is either over or not, if we're well-formed language. And for now, we expect everything to be well-formed, assuming that we are correct. So, yeah. So if index is not equal to if it's index less than n, then that means that we haven't consumed everything, right? So n is equal to length of expression, and then index is equal to 0 is how I write it, right? Then we parse op, and then we recursively parse the expression, right? And that should be good. Well, maybe, because then now we actually have to, well, I mean, I think there are two ways we can think about wanting to do this. One is that we can have the parser return an expression in Python that we can evaluate, or we can just have the thing actually evaluate itself, right? So instead of parse, it'd be like, you know, calculate or something. I mean, these are all like, honestly, relatively minor choices, but these are the things that you can do, right? So yeah, so this, right? So parse fraction, and we have, okay. So here we have an optional op or sign, I guess technically. I guess the sign is optional. So yeah. So parse optional sign, something like this, and then fraction is equal to parse. Or I guess that's not fraction, but I mean, you can write this in a number of ways. I guess you can also write this as like, because I think to be more precise, or maybe just easier, then fraction is this, or maybe you could even call a sign fraction is this, and then fraction is equal to actually this, and then kind of write it that way, right? I mean, I know that I'm maybe making it too complicated, honestly, but it makes like debugging a lot easier in general in the future, right? So you're putting some of the work a little bit early on to kind of get it right. Numerator. Did I just forget it? Okay. Well, oh yeah. So then now fraction is equal to parse fraction, right? Yeah, but then now in the future, it's not true anymore. But whatever. I guess that's fine. I don't know. I don't know. If you want to be, depending on how precise you want to be, but I guess that's fine, right? So then now, and then that's it, and then we would just return. It's a little bit awkward, I think. Because then now we want to return something like, I don't know, the sign times fraction or something, but how do I even write that? But then maybe just like fraction, maybe a new fraction with the sign. Maybe that's fine. I don't know, right? And we have to kind of implement this as well, right? So yeah, I know that I'm making this way too complicated. I think in general, if you really want to just like speed run this, you can just actually like tokenize on the only two things we need to, or two type of things we have to tokenize. One is the add minus, and then the other is just a fraction. I mean, this is actually way, like I said, I'm overkilling this a little bit, but in hopes that in the future, when you have a harder parser problem, you'll be able to kind of figure this out a little bit. So parse fraction, we just have, you know, parse number. So we have numerator is your parse number, and then we parse the, I guess technically this is assigned to, but whatever. And then now we also parse the, so yeah, so assert that in expression of index. Did I call this is kind of, let's just call this, let's rename this a little bit. Let's call it y. I don't know if that's probably worse actually, but oh well. But yeah, so y of index is equal to thing, and then denominator is equal to parse number, right? And then maybe we return fraction of numerator denominator. It makes this kind of a little bit awkward. I don't know how to like, yeah, maybe we need to figure out how to or like just do maybe I'll just do an if statement, keep it silly simple, right? So if sign is equal to negative, then fraction dot numerator, just, you know, something like this, and maybe that's fine. Maybe I don't, yeah. And the beautiful thing about writing it this way is that you can unit test every component, right? You don't have to worry about you could separate the responsibilities on your testing such that you don't have to worry about other things, right? Like this code, you don't worry about whether this code is wrong, or this code doesn't worry about this code being wrong, because you're unit testing all the components together. Okay, so then now let's let's define fraction, right? So we have like right? This is just basic stuff. Numerator, denominator, right? And then we have sub dot numerator is equal to numerator, sub dot denominator is equal to denominator, right? And we'll probably implement some stuff like add later on, fact2 maybe, and what else? I guess like, I think that's really it. Maybe like a helper function for like reducing or whatever, but I don't know, right? Like, I don't even know if this is quite necessary. I think it's probably fine. but these are the things that we need for this one anyway, assuming that we have a signed. So the approach we're taking is that we assume everything is signed but we just add everything, right? So yeah. Okay, so I think I'm missing this one. Parse optional sign and parse number. I guess I forget that one. So then okay, so then if e of index is equal to it in, technically it can only be, no, I guess that's not true, but yeah, that's good. So if this is not in, then we just return. Otherwise we consume. I guess we have to do a non-local index. We consume, and then yeah, and then we return e of well, so sign is equal to e of index, and then we just return sign, right? So this just make sure that we do separate that out correctly. Yeah, and because we're returning the fraction here, that means that we actually want to do the operation here in parse expression. So we have to kind of add some logic after this, which we will do. So it's fine. Oh wait, I lied about this. We have a parse op, so we're parsing the op, so we're not. So then every number is just going to be positive, other than maybe the first one. So okay, yeah. I mean, the parse op is also kind of the same, actually. I mean, we just it's coincidence that it is the same, but I think it shouldn't be. But yeah, I mean that's fine. I know the code is the same, but they have different ideas. You know, positive, negative versus add and even so. But it just happens that the code is the same, so it's a little bit awkward. What else? A parse fraction. No, we have parse, so we have parse number, right? So then now parse number, right? So then we have non-local index. We have if, and here we assume that it is okay. Actually, parse op. Oh no, index is less than n. So I guess we're okay. Yeah, okay, fine. Yeah, I think this is a little bit awkward about doing the math here. I think in general, yeah, maybe it's a little bit later on that, but I think in general, maybe we would just like pass up and especially if you have to deal with parens and stuff like this, maybe parse up the expression tree and not just like evaluate it, because it makes things a bit more complicated and there's not separation of responsibility. Because for example, here we can definitely just do like, okay, we have an operation and the expression will return a value, right? Expression here returns a fraction, so then we can just like add or subtract. But you could think about it in a parallel universe where, okay, what if there's multiplication and it takes priority? Well, then you can't just do a left to right thing, right? So you have to be a little bit careful about how you want to handle some of these things. But yeah, okay, so here back to parse number. So if x is less than n and y of index is in well, I guess just like is digit maybe, if that's true, then we can parse number. So then for now we just early exit. If this is not true, then we return. Actually, I guess this should flow, because in theory the way we set it up, it's not an optional number, it has to be a number. So we can just assert this is true, right? So then now kern is equal to 0, and then we just do a shift and add, right? So while index is greater than n and y of index is digit, oops, we add it by y of index. This is shift and add, not add and shift, so you know. Yeah, I think we should be good, right? Okay. I don't expect this to be correct, by the way, because we don't do anything yet. What am I supposed to return? Oh, a string. Then we also need a toString. just want to make sure that this kind of runs. I might run an infinite loop because I forget to. Yeah, okay. I was like, I don't remember doing this. But yeah, of course you have to consume it. Okay. Dong dong dong. We ran out of things. That is actually surprising, maybe. Where am I meant? Pause optional sign. We consume. Up. We consume. Pause number. Oh, here we don't consume. Okay. There you go. So okay. I mean, obviously we expect the wrong answer, but it's just making sure that it at the very least terminates. Okay. And then maybe just for kicks. Oh, I have to. So okay. So here we can just return an up string of new. We should probably reduce this, but we shouldn't reduce it here, right? Like we should just keep it as an invariant. Oh, I forgot to print it because I wanted to print fraction. Just that's why I wrote the to string. Okay, so that looks actually what we want, right? So that's pretty good. Let's actually use the other example cases before we do the add. Yeah, I mean, it looks good. So we're pretty happy so far. I mean, I know that I'm a little bit slow, mostly due to a lot of talking, but yeah. Yeah, and then here maybe we return fraction, and then we can just return this as the answer. I mean, it's not right because we don't handle this, just to be clear. Is that not a possible routed value for? Why not? I mean, it's the wrong answer, but it shouldn't be not possible. Yeah, also 32-bit thing, by the way, I forgot to mention this because I saw this earlier and I wanted to. It's obviously true just because 10 factorial is like what? 3 million or something, 4 million, so that's not a, and obviously 10 factorial isn't even cannot be the lowest whatever thing. I guess it could be maybe, but either way, I don't know why this is not a valid thing, honestly. Yeah, I don't know why. I mean, it's just the wrong answer, but it should be fine, right? Am I misunderstanding this? That's a little bit awkward, actually. Like, why is this? Am I doing something wrong? Just returning this string. But this is okay. Am I? Like it's. What is the difference between? Oh, I see. I see. I need to make it explicit because I think it confused things. Okay, that's fine. Oh, because I do pause expression twice, and that's the one thing that you have to. I think in theory, if you want to make this such that you can call it again, you would actually wrap it in, like I said, a parser, right? So that's why, and you should probably do it. That's probably good practice instead of putting in the main. But so then you can do it multiple times. So maybe we do that then. I mean, we already came. Parser. What am I doing? I mean, we already made an attempt to keep it clean, so why not? Right, and then now you can put all these things in here. Not like that, but this one I think. I'm just formatting. No worries. We do have to do self.expression. So instead of e is self.expression. And instead of n is self.n. I expect that there's some typos in the thing, which is fine. We're still just going for it. And of course, every step of the way, we would have unit testing, right? So it's self.index. I have to fix that too. Yeah, we should have yeah, unit testing for all these things now, so it should be good. Though I'm a little bit lazy today in terms of making, because these should all be private, but I there's too much copy and paste, so so yeah. So excuse me if I'm gonna skip that part. But yeah, maybe I just have a pause, right? Right, and then now we can write something like parser of E. I guess now we can call it expression again. I should have done that anyway. Right, so then now you have parse. So then that parse, and then we just return this. I think it's still return to thing, so you have to convert it to a string because it returns a fraction. I guess I'll put this into here. And the beauty of this, I mean, you know, is that you can do it multiple times. You can create multiple parser objects and have them not interfere with each other, right? Oh, non-local index. It's not in. I don't have to do non-local index anymore because it is self.index, which also is kind of cleaner. Maybe, I don't know. I'm missing it in a few places anyway. Actually, I just realized, yeah, I have to kind of call all these things. Yeah, well, sorry, friends. Give me. You can fast forward a little bit, I suppose. But yeah, my apologies. Oh, I have to change. Yeah. Just copy and pasting some things. I probably should have done this to begin with. Then it would be much, you know. But it is what it is. Oh, I still have non-local. That's the thing that I forgot. I might remove needing it, but it should be okay. Sign must be integers, not built-in or method. So that means that, oh yeah, because index it's a little bit confusing because index is also a name of a function in Python, which is why it's giving that error. Oh. I thought clearly I missed a spot. Still a spot. Man, there are a lot of spots I'm missing. But okay, so now we're Gucci with this part. Okay, so then I think the parse is okay. What we want to add, well, we do have a sign, so we also want to implement subtract. Just to be clearer, I know that you can write it in terms of, you know, negative whatever, negative addition, but you know. Okay, yeah. So then now, just in the interest of being lazy, we just write like if op is equal to then we have fraction dot add expression, else right. Yeah, that should be okay. And then now, now we can actually implement all this thing, right? But like I said, this is a good practice in writing a parser if you haven't done it before, for sure. Even though I've been taking a long time, way longer than I probably could have been, but or should have been. Like I said, you can just write, like you tokenize and write things and then just do it. And that's probably what I would have done in a contest, to be honest. I don't know if I've done this one before. Oh, I haven't done it before yet. That's actually surprising. But yeah, if I had to do it in a contest, I'd probably just do the tokenize thing and try to keep it short. But yeah, so let's do subtract first, right? So subtract, we can just do self.add frac2, kind of, right? So return this, but then maybe we write frac2 dot numerator, we just times it by -1, right? Something like that. Maybe in theory, well, no, this is pretty bad actually, because this actually modifies the input, so that's actually not what we should do. So maybe write like a new fraction that something like this. So create a new object so that yeah, I don't know if I like the way of doing this, because it makes reduce a little bit more complicated, but it's not so bad, so I think it's okay. But yeah, and then add is the only thing that we have to, because subtract, if we do a reduction here, it should be fine, right? So then now we have what do we have? We have a over b plus c over d, right? So then now we just have to multiply to get the common thing, so it's going to be bd, bd, right? So that's basically it. And then we can reduce later. So yeah, so then now we have new numerator is equal to self.numerator times frac2 dot denominator plus keep it consistent a little bit, numerator times self.denominator, right? And the new denominator is equal to yeah, self dot times frac2 dot denominator. I think there are a couple of things I want to point out about my thing, right? Is that self dot denominator is always greater than or equal to 1. So that numerator is the one that signed it. So maybe these are things that we should assert as well, just in case things goes wrong. Yeah. Okay, so then now we have these things, and then now we can reduce it. So yeah. I'm trying to think what happens when you have signed it things. I think this should still work, right? Oh well, this is what testing is for. So then now we can do a self dot numerator is equal to new numerator, self dot denominator is equal to, oh, this add is just in the way that I wrote this add is actually is like a plus equal to, not just a plus. Maybe you could return. Did I write it that way? Actually, maybe I didn't write it this way. I have to return it. Okay, so yeah. So then now we can just create a new object then. Maybe that's a little cleaner, actually. So yeah, so then now we can return new fraction, new numerator, new denominator, right? And I think it should have designs already in new numerator, but then when we want to reduce this, yeah. So okay, so f is equal to this, f dot reduce, and then we return f. It's not quite clear where we should put the reduce, but maybe that, like, you could also put the reduce here, but I don't know. Maybe that's cleaner. I'm not quite sure. Depends on how you want to use this as the thing. All right, let's actually put this here. Maybe that's a little bit cleaner. A lot of these things are maybes because we don't know. It really just depends on how we want the future to look like, right? Or anticipate the needs of the future. But I mean, for this particular problem, obviously it doesn't matter that much. But if you have like future needs or have ideas of how you want the future to look with your code, then maybe certain things makes more sense in certain places, right? So yeah, okay. Actually, I don't know how GCD works with negative numbers, so we might have to be careful about it. But yeah, but we can just write like GCD is equal to just the GCD of, and the denominator should be positive as we have it, and then self dot numerator self dot right. Fraction has no attribute type. Oh right, this should be afterwards, I suppose. I mean, just in case, I guess. Okay. I guess my math is wrong, but on this one, because it's not doing the subtracting, it added them to get 5, 6. But at least we're on a very, we are on a right idea. But why did this add? Do I consume the operator? No, this is consumed. So I worry about like the double negative or something. That's what I was looking for, but if it's consumed, then it should be okay. I don't know. Let's see. So yeah, so maybe put in fraction op expression. So then it is doing the subtraction. It is doing this. Oh, this is an F. I don't know why, and I don't need this anymore because of the way that we now make our invariants. Okay, just a minor typo. Ooh. Is that not true? Oh, it's 1/6. That's the thing that I wasn't sure about the signs, but oh, I have negative 1/2. That is just actually very wrong. Okay, so we subtract. Oh, what am I doing? Oh yeah, it's self.add, right? So I just removed this a little bit silly, but okay, there you go. We add the negative version of this, right? I don't know what my math. I don't know. It's just a lot of silly typos, and yeah, that's just silly the way that I wrote that. But yeah, it looks good here. So honestly, like I said, especially for these things, it's very easy to write unit testing, right? Because you know what the answer should be. So I think we should be okay. Maybe like negative, I don't know, 10. I think 10 is the one that maybe I would try. But let's run it real quick. But yeah, you can write a lot of these inputs, right? But I am a little bit lazy, so I'm just gonna submit it. But that said, that's just because I already spent 42 minutes in it on this video. But definitely, I think one of the important parts about having problems like this is writing good unit tests. So definitely practice on that. Debugging on yourself before you submit is actually a very important skill, and I've been kind of bad about it, I'm not gonna lie. But and I'm gonna do that now. So yeah, let's see. Ooh, okay. I mean, oh yeah. Okay. I actually did think that this might happen, but I kind of just forgot about it. That's why I was able to. That's why I am recognizing this immediately. So this thing, that is the issue with kind of evaluating this, because we're not evaluating it left to right. It looks like we're calculating it left to right, but that's actually not true, right? It's because if you think about this in a recursive way, then yeah, this is not right. What this should have happened is this should be a. Yeah, I want to write it as an expression, but then I'm doing the evaluations incorrectly. So basically what is happening, and I actually thought about this, but I just forgot about it. That's why I'm able to recognize this immediately, is that for someone like this, essentially what I'm doing is I'm putting paren here, so then this negative is giving me the wrong answer, which, makes sense. And it's also why I said, like, if you have a expression tree of the parsed thing, then it's just much cleaner, right? But because then now you could do the operation in however you like to do. In this case, left to right. I don't really have a great I don't really have a great way of doing this. in a good way without just doing I'm changing it so that's a little bit uglier, which I'm not happy about, honestly. But here, then now you just kind of keep on eating the fraction, so it's not quite the same as this. But keeping in mind that this just describes the language, not the evaluation of the language, right? Which is why it's a little bit different, and which is why I generally like to separate the logic. And maybe in a way, this is a cautionary tale. I mean, I'm going to fix this in a hacky way, but definitely this is not the way that I would fix it during, like, in a real software engineering situation, because this is not quite. Yeah, I would just, you know. I mean, another way that you can think about it, though, is that like if you want to think, if you really want to, you can think about this as like something like this instead. But it's a little bit more awkward to, I guess that's fine. But it's a little bit more awkward to try like getting this up in the last thing and try to identify it. But in theory, like you can do it that way, but I think that's maybe not the way to go. I don't think in general. But yeah, like I said, we're gonna fix this, but specific to this problem. So so I don't know. I don't know if I'm happy about it, because I did all this thing. I'm so tired, I'm not gonna lie. So yeah, let's give it submit now. Right, so okay. So I mean, I hope that was a demonstration of why you should have separated your parsing and your evaluating. But yeah, because I think how how you can also think about it. Let's actually, all right. I'm gonna try to be not lazy for now. Right. So then now maybe instead of doing this, I would just have. It's a little bit annoying as well, because what you want is actually like the expression is you go to something like this, and then maybe something like this. Is that right? I just want to make I mean it's mostly right, but it's just that I'm trying to think whether this is flattened. Is this flattened? So this returns an array. I guess you have to write it like this maybe. But this also becomes like n square-ish because of the way that this is written. Yeah. Which is definitely a little bit awkward. You can make it not n square-ish by a couple of hacks. But what is how many things do we given anyway? Only 10 numbers, so I don't know. I mean, I'm going to accept the n squared for now. I mean, there are ways you can do it, but it's all maybe yuckier. So then now you have like an expression is equal to this, and then now maybe you could do a while loop of like, you know, fraction is equal to this, and then for I don't know, n is equal to length of expression. Then now for ranging from the first to the n, multiples of 2, right? So then now we have like the operations, right? If xp of I is equal to plus, then fraction dot add I plus 1, something like this, right? So this would probably also be pretty okay. And And of course, you can also put this in like a different library or something, but I don't know. Oh, I keep on forgetting to convert this to a string, but yeah, and then yeah. So there are definitely like ways you can think about this, right? It's not even that bad. I mean, the only thing that's bad is just like this extend thing, which you can kind of. There are ways you can go around it by finding it once at the end, for example, but that's not actually. It depends how you represent your expression tree, but I don't know. Anyway, this is a very long video, and I know that I kind of did it the long way, but I just want to show you a different way of doing it. If you are looking for like a quick way, which you probably aren't 50 minutes in, like I said, there are a couple of easy ways to do it, right? Like for the parsing, we don't really need to, like let's delete the parser right now. Maybe I'll up south, or in this case, technically down south. I mean, the fraction class is going to be mostly the same anyway. Maybe I don't write it in the library, so I don't know. But basically, if you don't have the parser, right, which we already submitted, so you could. Oh, actually, before we'll show you the code later anyway. Actually, let me just show you the code now, right? So here, this is the fraction class. This is the parsing class. You have parse number, parse op, parse optional sign, parse fraction, parse sign fraction, parse expression, and then this is the evaluation, right? But let's say, so you can parse during most of this, hopefully, you have the technology. But yeah, let's say we don't have this, then what I would do maybe is just something like, maybe I'll keep this just because I'm lazy, but you could do an expression dot split of, I forget how split works in Python. Let me double check real quick. Like, can I split two things? You can only split on one thing, right? It's not a because with regex you can split on like either or. Yeah, and maybe you can just do like a group by thing. Maybe that's a hack. So group by I think. I don't remember the exact expression, but like something like this or something, right? So let's comment this out real quick. So this is the upsolving in. Let's say if I wanted to get this as quickly as possible, right? What's it called? Oh, just group by, I guess. Not dot group by. Okay, so then now you have for what's it called? The group value or the value and the group. And I'll just put this here. Something like this, right? So then now you can always see that we have. Oh, that's why. But yeah, okay. Yeah, I was wondering why this negative was there, but okay. Yeah, and you can see that now we parse out the negative and plus, and then now, yeah, right. So pretty straightforward. Maybe you write something like, maybe I'm lazy, so you could probably do the same thing as before, right? So you have this. We have expression that. I guess if we demonstrate as an operation, then we just append g of, like, technically it's an iterator, so you have to be careful, but you just write this, and then we can. So then if it's an operator, then we do this. If it's not an operator, then we append and we convert it to a fraction. Oh, I guess we didn't pause this. Oh, then now it's a fraction. So then now we do yeah, if it's a fraction, then we just do a easy hack, which is g.split of, oh, actually not, it's join g, right, will give us the string. So fractional string, and then now we split it by the thing, so then which is the numerator and denominator, right? And then now we can yeah, and then just new fraction, right, of numerator, denominator, and then we can append this. And then now we have the expression thing that we have here, basically, except for the first thing, right? So so we have to check if expression of 0, if it's a sign. It's a little bit awkward, honestly. I guess it has to be negative. So if you go to negative, then as a hack, you can probably just say it's negative from 0, right? So then maybe like as you go to fraction of 0, 1 plus expression, something like this. And this is linear, but I don't know. Like I said, this is if I'm trying to do this as fast as possible, right? So then you could, and the rest is actually the same way coincidentally. Absolute value. I mean, these are strings, that's why. So I have to do int this. Oh, whoops. Just 2 string concatenated, and as you can see, that works. And that's basically what I would have done for the parsing if I was trying to do it as quickly as possible, right? Just getting out the things. Yeah, this is a very long video, and yeah, this is the parsing thing. We always show you the fraction, right? So yeah, this is a very long video. I did it 2 different ways. Hopefully that is good and understandable. Yeah, and this one anyway, I guess we didn't go over complexity. It's going to be linear time, linear space. I mean, everything here is linear, so hopefully I don't have to explain that much about the complexity. So yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Yeah, stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye-bye.